folks, I'm Keith Bowen and this is Hard Rock University. Last fall I gathered together a bunch of samples from a number of different locations and sources. We have a company in town here called Skyline Labs. They're a really good quality assay house, but they deal in big customers, and so their minimum order's $300, which is like 13 assays. So I like to use them, but it's best to have a pile of samples before you do it. And so I gathered a bunch from a bunch of different things, and I'm going to go over those now. Starting with the ones where I've actually done videos, with the exclusion of the ones from Ryan's, which I'm going to make a separate video on that 50 kilogram test extraction I did. I'll do a whole video on that in the next week or so. But let's start out here. First of all, at the Good Enough mine, I took Anders from Sweden out there for a interesting day, and most of the samples came back pretty discouraging. So I took the best sample I got for the day and sent it off for assay. And if you go in the main portal and go all the way back to the end of the adit, the working face there, I got a sample that ran an estimated 0.05 ounces per ton. Okay? Now, the assay from that came back at 1 part per million, which is 0.003 ounces per ton. The reason they do parts per million is because the rest of the world uses metric. Parts per million is grams per metric ton, and so they deal with a lot of international companies. Everyone's used to those numbers. That's what they use. So then I translate. The way you do that is you multiply parts per million or grams per metric ton times 0.029 and you get ounces per ton. And so my pan said 0.05, the assay said 0.003. That's not really good agreement, and I came up with a higher number. It's possible that my pan was contaminated because I'm usually dealing with some very high-grade materials. I'm dealing with concentrates, stuff like that. If I didn't get my pan really clean, that might account for that, or it could just be sample variation. I do a 2-pound sample. They do a 30-gram sample that they finally do, so it might have just been something like that. It does happen, but not good agreement, but neither one really matters. They're both way too low to be exciting. Now the next location is Grant's mine in the Panamint Valley. Now even I went there in November, had a good time. There was a get-together. We had a really good time. It was quite dramatic scenery too. But anyhow, Grant's mine is up on the side of a hill. That's the main access level. And if you go in there after, I don't know, 100 to 200 feet, something like that, you wind up kind of teeing off. To the left, there's an adit that looks kind of more like an exploration adit than any kind of production down there. To the right, the track continues on that direction. There's a couple dead-end drifts, but there's pretty significant development there, considering they weren't actually doing any mining anywhere. But right at that location, there was some mining. There's a decline, well, I guess an incline from where we're at, with a metal ladder up it, and I'm guessing that that was the original discovery, was the outcrop on the hill above. They went down, they sank down along that, and then when they got deep enough, they decided to drive a tunnel in through the side of the mountain to vastly improve their access. But anyhow, at that location there, just past the ladder on the track level, there's a wide spot in the tunnel, which, you know, leads me to believe they were going after some ore there. So I sampled that, And my pan I estimated at 0.1 ounces per ton. Now when I sent it off for assay, it came back at 0.18 ounces per ton, or 6.17 parts per million. Now that's reasonably good agreement. You know, with a pan, and just judging it by eye, to get that close, that's reasonable. I'm not unhappy with that at all, although the grade itself is a bit low for profitability. At that same intersection there's a slide. It looks to me like they had containers of ore, maybe just buckets, that they were dragging up that with a winch. And so at the bottom of that, if you're looking back at the slide, to the right, there's a little veinlet of what looks to be limonite or limonite enriched material, and then next to that is wall rock. Now, as my usual abundance of caution, they were mining a lot of that wall rock, so I just took a sample across both, but I was kind of preferential on the limonite there, and it came back about 1/4 ounce to the ton. Grant went back the next day and took 2 samples there, one from the limonite material and one from the non-limonite, apparently fairly poorly mineralized wall rock. Limonite didn't come back very well. The wall rock did. I estimated 1/3 to 1/2 ounce to the ton in my pan. So sent that off for assay. It came back 0.374 ounces per ton. That's 12.9 parts per million. That's just getting into the profitability range for a micro-scale operation. It's pretty marginal at that. That's about what Ryan's ore is running. And I'm very interested in that because I want to try and develop equipment that actually makes that profitable. If it does, if you can make a decent living at 1/3 of an ounce to the ton, I know a lot of mines that you can make a decent living at. So there's a reason why I'm striving desperately to get profitable at that grade level. Obviously, it'd be much better if it was much higher. It's an interesting result because it wasn't in a small formation. It was fairly large, no clear boundaries, and therefore if there's a large volume of rock, then you can increase your tonnage, going to something, either a large tonnage underground operation or a surface operation. If that grade extends through the mountain, or even if it's 1/10 of that through the mountain, you might have an open pit heap leach operation that you could lease to a larger corporation. So it's worthwhile for him to spend more effort, although not a whole lot more money, doing the speed prospecting techniques, where he's taking samples, crushing them, panning them to determine the general concentrations and distribution of the gold, with just the occasional assay to verify that the technique is continuing to work reasonably well. But in that mine there, the hand panning technique seemed to do quite well in determining where the gold is and a close approximation of how much. Next location. Now this is where Chris from Bullhead and me went up north of Kingman there with Eva, looking for a claim that a man named John was leasing. He'd never been there, so he wanted us to find it, take some samples, take a look at it, and give him an opinion on it. So, we took a number of samples. You've seen the video. And by the way, all the videos I'm mentioning, there will be links in the description. But anyhow, I went out there, took some samples, and I was quite surprised at how little gold I was seeing in my pan. There were several pans, I got 0 detectable gold. Now there was enough workings there. It obviously wasn't just a prospect pit. Now there were prospect pits and little dog holes and stuff around there. This was not one. They were actually mining something. So that really piqued my curiosity. I took the best looking sample I could find, and that was up on surface. They had dumps, and one of the dumps had a subsection, the north dump there, part of it was a heavily iron-stained material that had obviously been hand-selected and piled up in one spot. Now that's a real good indication that that's some good stuff, okay? You don't hand sort for no reason. So I assume that this is probably what they are interested in, that this is where they would pile it up before they'd ship it off or whatever. Just a guess. Now, in the pan I was getting a trace, like maybe a 0.01 ounces per ton estimate. Okay? The assay came back 0.08 ounces per ton, which is still too low by far for a microscale operation, but not necessarily for an open pit heap leach. By the way, that's 2.64 parts per million for everyone outside of the United States. And anyhow, still didn't seem to justify the amount of work it's done. This wasn't a big mine, but again, it's not a prospect pit. They were mining something. So I also did a silver assay and a 30-some element analysis. And the 30-some element analysis also does silver. Now on the 30 element analysis, the silver was above detection limit. Okay, there's only certain things they can measure accurately. Below that, they can't measure it all. Above it, they can't measure it accurately. It pegs the meter. And it was 100 parts per million was a detection limit. It was higher than that. On the fire assay for silver, it was 881 parts per million, which is 25.5 ounces to the ton, which at current prices is about $400 a ton. Now that would indicate why it was stockpiled there. However, this is a small quantity of the overall rock in the hillside. When we were looking at this, we didn't find a veinlet of iron-stained material or anything. There were little teeny pockets and little veinlets and things like that that are just not continuous enough to have any tonnage. So you'd have to figure your ore waste dilution factor of 10 or 20 or 100 to 1. So now your $400 per ton goes to 40 or $4, somewhere like that. Again, not useful for our purposes. But that would indicate why maybe somebody was drilling north of there about a mile. Now, other interesting elements were arsenic at 1,000 parts per million, iron at 7.92%. Now that's why it looked iron stained, because that was a lot of iron oxide there, absolutely. And lead at greater than 1%. Again, above detection limit on both of the arsenic and lead. There was a mineral there that was kind of yellowish, kind of a faded yellow, that was really heavy. Perhaps it is a lead compound. There's also 2.25% sulfur here, so there should be some pyrites there or something. Perhaps that heavy mineral is a lead compound which contains silver. I don't know. That's not my area of expertise, complex mineralogy like that. It also means that your extraction to saleable metallic silver is going to be more complex. You're likely going to have to just make a concentrate and ship it off to a refiner. None of these things are helpful, especially the arsenic, but it does explain why my panning showed so much less than the assay result. Arsenopyrite ores, let's pronounce it properly. Arsenopyrite ores tend to have really, really fine gold, which doesn't pan worth a crap. So that explains the discrepancy between the pan and the assay results, and means that in this particular thing you should throw that adjustment factor in there. Now, another couple possibilities for the heavy mineral is barite or scheelite. Now, scheelite is a tungsten mineral, and there's only half a part per million of tungsten there. not enough. It's not scheelite. I was thinking it might be uranium oxide, 5.56 parts per million. No, it wasn't uranium oxide. Barium, 92 parts per million. That gets it possibly. It might be barite. It would explain a number of things. But then I'm also not seeing where the lead is. Again, it's probably not lead, so it's probably not galena. Probably has oxidized or decomposed some from that, and there's minerals there that I'm not familiar with. But anyhow, it looks like a fairly complex ore. Small pockets with lots of waste around it. Not very profitable, and not much gold. Okay, so not really suitable for a microscale gold mine. Now, there's another couple of samples here that came from people that got included in this, which I have not done videos on for a number of reasons. Chris, up in Bullhead, your sample marked SSR is 0.06 ounces per ton. That's 1.95 parts per million. Unless you got a mountain of it that could be heap leached, not worth anything. Terry lives up in Chandler, has mine up in Nevada. The pyrite dumped sample, 0.07 ounces per ton, which is 2.47 parts per million, and especially being high in pyrite, which is probably going to encapsulate some of the gold, unlikely that that would be valuable. You're looking at heap leaching grades. You'd need to have a lot of tons, and it would have to leach fairly readily, and if it's got a lot of pyrite in it, that's unlikely. So you got kind of refractory metallurgy there. Now, we made a concentrate from that while he was here, and Skyline apparently doesn't do concentrates at standard prices anymore. They're concerned about the very high concentrations of certain elements, gold, silver, copper, contaminating the crushing and pulverization equipment so that it would give anomalously high results on their lower grade materials that they're pushing through for geochemical assaying and stuff, where they're taking samples over an area trying to find something, and they have to look at much lower concentrations, these big mining companies. So obviously, if you were to contaminate the equipment to where it's giving them incorrect, slightly incorrect figures, but going from like 0 to 0.01% copper, yeah, that could make them do some very expensive wrong things, and I can see why they're concerned about that. But anyhow, the price is now like 10 times the cost of a standard sample, so I did not do that. And that means, Terry, that I owe you 30 bucks. You can either keep that on credit for future use, or you can ask me for a refund. I'll send you a check or whatever. But that just didn't happen. Because the head ore was only 0.07, it's not terribly important in the first place. And the back sample from the same mine was 0.03 ounces per ton. Again, only useful if it's heap leachable, which means big tons and not too complex. And that would be 77 parts per million. So those are the samples that I'm reporting on today. Orion's 50 kilogram test run. I'll be doing a separate video on it within the next week or so. And I'm going to get into the mass balance equation and how to determine how much gold you start with, where it's going, how much you're recovering, how much you're losing, where you're losing it, why you're losing it, and stuff like that. So that is going to be a separate video, and that gets me caught up on all the assaying, and I appreciate the patience. It took longer than expected, although I warned people that it might, but I feel a little embarrassed that it took so long, but many of the factors were pretty much beyond my control. So anyhow, those are the results. Everybody's got a copy of the report emailed to them and such, and we'll go from here. And that next video is going to be really interesting on Ryan's ore. So Happy prospecting and keep it safe out there.